Hello, everyone. This is Alan Schemmel, Editor-in-Chief, DevOps.com, Media Ops, Security Boulevard, Container Journal. Welcome to another great DevOps.com webinar. Thanks for joining us. We have a great webinar lined up today on why distributed tracing is essential for performance and reliability. I wanted to, before we jump in though, just go over a little housekeeping with you all. We do use the GoToWebinar system here at Media Ops, and that means for most of you, you're going to see a GoToWebinar control panel in the upper right-hand corner of your screen. I want to just familiarize yourselves with two parts of this control panel. The first part is the one marked questions. It's about halfway up. And if you can hit the little arrow so it's pointing down, and you can expand the section, you can see that you can type your questions in there at any time. It's really great for a number of reasons. Number one, once you type your question in, it's queued chronologically in our system. And when we get to questions, we'll have it in there. We'll start from the top, work our way down. If for some reason we have so many questions we can't answer them all, that's okay. We will have a record of it because it's entered in here, and we can try to email you that offline if we haven't answered your question. All your questions are important, and we do want to answer them. Secondly, I wanted to call your attention to the chat section. Chat section's all the way down at the bottom. And again, if you click your arrow and open that chat section, you can see that you can chat there like you can in many chat applications. The deal with our chat here at Media Ops is that we use this for technical difficulties. So not for a question for the speaker on subject or what have you, but for some reason, maybe the slides aren't advancing, the audio is bad, whatever, any technical issue, but you can still get to the chat window, type your question, your problem in there, and we'll reach out, and we have people standing by to help you. It's our aim that you get the most out of this webinar. It's a really great webinar. We don't want you to miss it. So chat for technical support, questions for our presenter. And I'll answer this right now. Our presentations, our webinars are always recorded, and they will be available on demand probably within an hour or two after going live today. So with that being said, let me jump into what we've got in store for you today here on our webinar. As I mentioned, the title is Why Distributed Tracing is Essential for Performance and Reliability. Our presenter today is Austin Parker, Principal Developer Advocate at Lightstep. And Lightstep is the sponsor of today's webinar, and thank you to them for it. Austin has presented with us before, and he does a great job on these webinars. I think you guys are in for a treat. With that said, let me turn it over to Austin. Are you there?
Yeah.
Go for it.
I'm here. All right. Hello, everyone, and welcome. Good morning, good afternoon, good whatever time of the day it is for you. And I'm really happy to be back here doing another presentation with the fine folks at DevOps.com. So, as mentioned, the title of the talk kind of gives it away, right? We're going to talk about distributed tracing and why it's essential for performance and reliability. But we're also going to tell you how to get business value out of it, right? I think if you come to a lot of these webinars or you go to a lot of talks, maybe you'll see this kind of cool new technology presented to you, and it's got a lot of bells and whistles, and it's like, this is great. But there's always that missing piece, right? Of how do you make it work for you in the, how do you make it work for you in the business? So I hope that I can get some of that across. Now, before we go on, I want to tell you a little bit about who I am. So I'm Austin Parker, as mentioned earlier. I'm Principal Developer Advocate at Lightstep. You can get in touch with me. Twitter I'm on Twitter way too much. You can tweet me at Austin L. Parker. You can also email me, austin@lightstep.com, with any questions. And a lot of the stuff I'm going to talk about today about distributed tracing, I actually wrote a book on with some friends of mine called Distributed Tracing in Practice. It's available from O'Reilly. You can find it at local bookstores or anywhere else fine books are sold. And all royalties go to the Anita Borg Foundation. We don't actually make any money off of it. So if you want to learn about distributed tracing and do a little good in the world, then give it a look. So let's start off with a question. And it's actually a question in two parts. Whenever, I still work with systems, and before I actually got into developer advocacy, I did a lot of DevOps at a company called Apprenda. And whenever I would get paged or whenever something would break, this was always the question, right? What changed? But I think when we talk about tools like distributed tracing, we have to step back a bit. We also have to look at what has changed about the way that we work, and why did those changes lead us to the place where we need tools like distributed tracing? Because I think if we can understand what created that need, then we can understand how to get value from it. Now, the first thing that's changed is technology. We've moved from bare metal machines to virtual machines to containers, and finally to these orchestration tools like Kubernetes, right? And each of these has provided a lot of new abstractions. Those abstractions are great. They make it easy for us to work faster and be more productive, but they've also added a lot of complexity and a lot of ways for our systems to fail in new and exciting ways. Now, through those technologies, we've been able to change the architecture of our applications, right? Microservices, service-oriented architecture, things like that are all enabled by these technological changes. And all of those changes have led us to create teams that are able to not only scale services more quickly, but also to fix bugs faster, add more features, deploy those features to production more rapidly. And that's the other change, right? This DevOps movement, this idea of bringing kind of your developers and your users closer together. That has been a huge change in the way that we think about, what is the definition of done in software? How does software get built and deployed? We've managed to combine all of these technological changes and build a new type of team that has a lot of autonomy, but a little less visibility, right? We've created a lot of challenges for ourselves in understanding what's happened in our system. Now, in any system in production, any software system, but also a lot of other systems, this is something you can apply to aeronautics or public transit even. There's a feedback loop. And on one side of this feedback loop, you have the concept of control. These are tools and processes, right? This is how you affect change. Now that can be things like Kubernetes for actual container deployments, but it's also service meshes, right? It's configuration management. It's deployment management. It's how you define a deployment. These tools all help you control the state of your system. And on the other side of this feedback loop, you have observe. And this is how you gather information to understand how your application is working, or not, as the case may be. And we've had tools to help us observe things for a long time, even if the names of those have changed slightly. But if you look at kind of the last, let's say 10 years or so of, enterprise software, just software development in general, we've had a lot of innovation happening at the top half of this, but not so much at the bottom. It's like we've built a very, very fast car that we forgot to put a speedometer into. This is really problematic because, not only have we added problems for ourselves in terms of, creating all these teams where you can go and you can do things faster and do things better, but we can't actually understand the changes when things break, and that leads to sort of a sucking effect on productivity, right? And this is because things in the top half of this feedback loop, the things you can control, this is something that can be done on a team by team basis. My team might need configuration, a config management KV store and another team might not. I might want to use more features of Helm than another team does. But that isn't enough. We need something that gives us this bottom part. And this bottom part needs to kind of be universal. It needs to be across our entire organization and across all of our different disparate sort of little structures we have. Now, this is where distributed tracing, I think, comes into its own, because it takes a request-centric point of view. It can show you how each service, each individual component that's being deployed by a given team, it can show you how that is fitting into the whole of what an actual end user is doing to your system. And this distributed tracing solves both the technical problem of like how do you do this, but also like the organizational problem of how do you address the effects of this broken control loop. We see this broken control loop in stress, right? Now that teams have a lot of control over individual services, it also makes it easy to add dependencies, and now your service is actually kind of implicitly and explicitly tied to a bunch of services you don't control. And that that's everything from like another team is launching a service that you depend on, but it's also things like managed services, right, or external APIs. And all these things you don't have control over, but you're still responsible for, because if they are slow or they go down, that affects your service. That is stress, and that stress leads to things like burnout. It leads to just really bad outcomes for like the individual humans that make up our teams. So if we're going to bridge this gap between control and responsibility or control and observability, then we need to think about this in two ways, right? We need to not only address the technical part, but we need to address like the cultural part. So to take a step back from this, if you're familiar with distributed tracing, you probably heard about it in the context of like this was something that big companies do, like Google or Twitter. And it's true, right? These were companies that were dealing in sort of global scale in a way that a lot of their peers weren't. And the thing they were trying to fix was that teams didn't have the data they needed to understand the problems they were having. Because there was a lack of data, they couldn't set the appropriate goals in terms of addressing these performance issues. And then because they didn't have either of those, they couldn't actually let teams have specific ownership. And I think this is why you see, if you look around, you'll see a lot of individual heroics, even today, even at like large companies, where performance and reliability is sort of passed off to either tiger teams or individual SREs or people who we kind of take this and we move it out of the critical path of like, okay, developers should own this, and put it on the back of someone else or some other specified team. So I think distributed tracing helps close these gaps, both organizationally in the sense that it gives individual developers and ops people and everyone more ownership of performance, but it also helps fix the technical question of like, well, how do you do that? And this talk really is about not just distributed tracing. It's part of how does distributed tracing fit into like your larger observability strategy. What is observability? It's the ability to go from effect to cause. It's something that helps support that process. It's like I can use an observability tool to understand why something happened or understand what caused the change. If we go back to the original question, what changed? Observability is having an observability culture and having observability tools and practices means you can always answer what changed. Now there's some examples here, but I think what's important to remember is, observability is not something you can buy. It's not like an off-the-shelf product. It's a combination of things. You need data, you need analytic tools, and then you need practices to take advantage of all those. If you have a system where you can look at these three things, right? Spike and errors, misconfiguration, If you can navigate from those effects back to their causes, then you have observability. It's more of a state rather than a specific thing that you install. So how do you get business value from tracing and by extension observability? There's three things I want to talk about here. So we're going to kind of bookend this between sort of these fundamentals and deploying tracing. So you're going to see value in developer velocity, you're going to see value in software performance, you're going to see value in managing cost. And we'll talk about sort of the fundamentals of these first. So distributed tracing. It's a tool, yes, but not all tools are necessarily the same, and not all ways of doing distributed tracing are created equal. I think it's actually, you might be familiar with distributed tracing if you use APM or things like RUM or synthetics or stuff like that. Like there are a lot of sort of applied technologies that use distributed tracing, but as I'll kind of go into here, it's not all necessarily the same. This is, if I say, hey, what's a trace? A lot of people will think of something like this, right? This is a visualization. This is an icicle graph of a particular request going through a system, or it kind of looks like a Gantt chart. And we can see these throughout multiple tools, Jaeger and Zipkin, and I think this is App Dynamics. But these traces are building blocks, right? Some people will look at this and say, like, this is the result. This is what I want to get to. But I think that this is really the starting point. So if I try to define all this, traces are a type of process telemetry or system telemetry that are based on spans. And a span is a unit of work. And those spans have a structure. So tracing is diagnostic in nature, though. If you're using tracing, it can reveal things like coordinating services to handle requests. You can view, how does this entire request look from the perspective of, my mobile app, all the way down to my database and back. And it includes, things that you're maybe used to, right? Like it can include logging data. It can include annotations or metadata about a particular request that help you filter it and categorize it and group it. It provides this request-centric view of the application. And when I say request-centric, I think what I actually want you to hear is user-centric. Because to an end user, to someone that is consuming your service or product or tool or whatever, they're really thinking about it in terms of requests. They click a button, something happens. They click add to cart, it should be added to their cart. They click play on an MP3, on a song, and it plays. But that's all request response, right? That most 99% of the time, what they're thinking about is how long is this taking or why isn't it working? And to a sort of internal consumer, to someone who depends on your API internally or your service internally, it's the same thing. They send a request for an updated, user, or they say, hey, here's some data, do some ETL, right? Those are requests, and those are also users you should care about. But that structure I mentioned is important to how you understand this. Unlike, traditional logging or metrics or anything, traces encode relationships between your services. You know where something ends and something begins. So in this case, the lines here, these are actual RPCs, remote process procedure calls between services. And the length of each of these bars is how long is something taking. So when I come back in, it's, you can see, I think between like yellow and green here, yellow is calling the green service, and then green is returning some response to the yellow service. And then the yellow service is calling the green service and the blue service to return a result to the pink service. As I said earlier, this is really just the raw material. It's not the end result. They're structures. The art of distributed tracing is actually about getting value out of that raw data. If you want to learn more about this, I point you to this paper that one of the co-founders of our company, Ben Siegelman, wrote when he was at Google. And they built a tool called Dapper, which is actually still in use. I want to say from talking to them, this was actually built in the mid 2000s, so even earlier than the paper, and it's still in production today there. And a lot of the stuff in this paper, is 10 years old now, but foundationally, it's really what comprises most distributed tracing tools on the market today. And then I'll also throw another plug in here for the book, what goes into a lot of what I'm talking about in more detail. So now that we've talked about what are traces, right? What is a trace? It's this thing that lets us view our application performance in a request-centric way, in a user-centric way. How does this get us to our use cases, our working value? So the first is velocity. Now, there's a lot of ways you can improve developer velocity, and I'm not going to talk a ton about like this first one, this idea of doing common tasks faster, because there's one, it's very dependent on kind of what you have, and also it's kind of simple. If you can deploy a change, if you deploy a change and you know what happened because of that change, then you're going to be faster, right? You spend less time validating deployments. But I think these other ones are more interesting. Understanding alerting, understanding dependencies, and then defining SLOs. So let's talk about this root cause analysis piece. This is a screenshot of Lightstep, and this is an internal service we have called Crouton. It's basically an API server. So someone noticed that, if we look at this error, this error graph, that suddenly the error rate increases, pretty dramatically. Now it goes up to like 0.35% over, 0.0 or 0.1%. But either way, like we know that there was a change in something, and we want to look and see what that change was. So what we're using here is trace aggregates. If you look at the baseline and regression here, we're actually taking a selection of traces over time and comparing them to each other. And we can then go in and we can do, start drilling down. We can say like, okay, what do these things have in common, or what is dissimilar? So in this case, we look at the logs that were attached to these traces. And we can actually see in a different service called LiveView that we have these log statements that weren't in the baseline, right? They weren't, if you look at the blue one there, you see no logs found. But in the red side, you do see like, oh, there's a bunch of logs about illegal base64 data. And this is highly correlated with our original symptom, which is that increased error rate. So we were able to navigate across these services, able to navigate across these services, an error that appeared in Crouton, actually find the root cause of that in LiveView simply by comparing, traces to traces, right? This also lets you get more actionable alerting in your software. So this is a PagerDuty notification, and you can see where it says links here. We have PagerDuty set up to take all of our alerts to kind of link back into Lightstep to show us a trace. So you can click on that. This was in the middle of the afternoon, so I don't think anyone woke up for it, but it was a critical alert. So we were able to kind of say like, okay, someone gets paged, they can click on this trace and they can actually see in depth like, well, what happened, right? And they can navigate back from this into a different workflow to, see what changed. And having that context, if you compare this to maybe the traditional, your traditional idea of like, I got paged because some metric was too high, the error rate was elevated over 5 minutes. It's like, cool, what does that tell you? It just tells you that something's wrong. It doesn't give you any kind of information to help you understand where or why. If you're interested in learning more about this specifically, I want to point you to a talk from SREcon and Mia back in 2019, who's Luis Minero. He's a SRE at Zalando, and he goes into a lot of depth over about how they use distributed tracing to kind of surface these insights for people that are on call, for people that are responding to pages. It's a really interesting talk. So the next thing is dependencies. So to step back a minute, If you have a distributed system, you have a lot of dependencies. And there's a couple different classes of these dependencies. There's sort of the simple model, which is the simple idea of it, which is, you know, library dependencies, right? Like my service depends on X library, Y library, Z library, but you also have other services you depend on. You have managed services, right? Maybe you're using some sort of managed SQL database or NoSQL database. You know, you depend on that. Um, maybe you depend on an API from a third-party, geolocation provider. Whatever it is, as those dependencies change or as their availability changes and the reliability changes, then this can cause really strange and traditionally difficult to diagnose issues in a distributed system. So let's split this apart. If I have service B, which talks to service C and service D here, and I maybe get paged because I see there's like a 8% error rate from D to E. And it's like, well, that's bad. But why is it? Is it because the request rate from B to D increased? Or is it because, the response size from C to B increased? And these are things that without tracing, you kind of have to evaluate in isolation. You can see these three data points, but you can't see them in the context of each other. Now, we could infer in this case that, if D relies on that response from C, that maybe something changed in C that is actually causing our downstream issue in E. And this is stuff that, again, if you're just looking at like metrics, you're just looking at logs, like you'll see each individual part, but you won't see the whole, and it'll be difficult for you, especially if all of these services are managed by different teams, to be able to kind of correlate, oh, the problem in E is caused by this increased response size in C or from C. It's a good watchword that in a distributed system, everything is always changing, and also things are always going wrong. You're kind of in a perpetual state of brokenness, but sometimes the things that are breaking aren't the things that matter, or things can be broken in an okay way, or they can be broken in a bad way. And distributed tracing helps you understand that. It's not enough to understand that A talks to B. It's not enough to understand that one thing connects to the arm bone's connected to the elbow bone, right? What you need is this context, and you need to be able to refine searches and queries based on any property of a request, and you need to be able to link all this stuff together. This is what saves you time, right? This is what keeps you from having to kind of have 4 or 5 different tabs open and going between them, and then doing grep in your terminal to try to manually correlate all these different facts and pieces of data. And the worst part about all this is that this is a problem that feeds on itself, because the more complexity you add, the larger your system gets, then the more moments and the more opportunities you have to get these sort of weird cascading failures. And if you don't understand it, then you're gonna end up in this like Netflix sort of situation, right? This is a Netflix microservice graph, and I think these are popularly called Death Stars, just the way it looks, where you can see here that like pretty much every service is talking to every other service. There could be ways that this could be done more efficiently, but if you were trying to figure out like where the needle is in the haystack, and like if my service goes out, or I replace it, or I refactor it, like what's it gonna impact? In something like this where you have such a high level of connectivity, you don't know, and you can't know without something like distributed tracing to help guide your way. So traces are going to help with that sort of highly complex situation because they're going to give you context, right? And that context can do things like make it easier to onboard people. If someone's coming into the team and says like, well, how does this all fit together? You just show them a trace. It can really help facilitate postmortems, incident analysis and discovery. If you're trying to figure out what broke, why, when, where, then tracing provides a lot of raw data that's super useful for that case. It can help you plan the future. When you're building out new features or you're building out new architectures or you're just trying something different, then tracing kind of helps you know where you've been. One thing, there's a story I always like to tell. And what it was is from a pretty large company, and they started using tracing. And what they found was they had a lot of really weird sort of bugs that were at one where they were hitting a cache 5,000 times every request, and it was so fast you really wouldn't notice it. But each of those, those nanoseconds, that adds up when you're doing it 1 million or 2 million times a day. And the ability for tracing to help them visualize, their service dependencies and visualize how this service was interacting with the caching layer made it very easy to not only find that issue, but also to give them something to know what to look for, in designing new architecture and expanding their system. It's also really good for things like capacity planning, because it lets you kind of spot problems early. It lets you see what's the change in request rate over time to this particular API endpoint, and then figure out is it going to be busy again soon? And finally, SLOs. So if you aren't familiar with SLOs, they're actually just extremely useful. And I'm actually going to recommend a book on this. I don't have a slide for it, but the basic idea with an SLO is a service level objective, and you use these to measure the reliability of your services. It gives you a lot of opportunity, a lot of power to do things like set an error budget and hold and set accountability for teams in terms of uptime. And it's an extremely good way to sort of create rules of the road, for service teams, and be able to say hey, if you're going to deploy something new or you want to make a change, here's the exact amount of time that you can sort of be down over the course of a year, right? Or this is how many errors you can play with. And it also gives you a lot of freedom and flexibility, because it means that you can look at your SLOs and you can look at your error budget and say well, we have a bunch of downtime we haven't used, so we can kind of be more adventurous. The book I want to shout out, I can't remember the title of it, but it's by Alex Hidalgo. It's out on O'Reilly in digital formats, and I think print is coming soon. But I think it's Understanding SLOs. So if you go look for that one too, that one is very good. And if you're interested in SLOs specifically, I think it's probably the best text on it out there right now. But traces help you, traces, again, distributed tracing gives you the raw data and the analytic features that you need to set these SLOs and understand all that stuff. So, software performance. We talked a lot about how does tracing help you with developer velocity and kind of helping you make it easier to write good software. But it also makes it easier to write good software in a very real sort of performance-y sense. So if you think about performance, what does performance mean? Well, at the end of the day, performance is really the performance of someone that's using your tool or your product. Like I said before, it's the performance of someone clicking add to cart or subscribing to a newsletter or whatever it is that your software does. Maybe a good way to think about this is to use public transit as an analogy. So let's say I have, if I'm designing a public transit system and I say well, I want the buses to get around as fast as possible, so I'm going to make them all go very, very fast. Well, that's great, but to my actual end users, who are people trying to ride the bus, it doesn't really matter how fast the bus goes. It matters is how long do I have to wait for a bus, and how long does it take me to get to my destination on the bus? So really, there's all these things outside of just the top speed of the bus that don't matter, or I'm sorry, that do matter, and the top speed of the bus might not matter much at all. Overall latency is probably the thing that we want to track the most here, but there's specific interactions in that entire, in the entire portrait of your application that are really, sort of the critical parts. Tracing gives us a handy way to think about this, which is a critical path. So the critical path is basically the part of your software where you're waiting on something to happen. So if I look at this, the yellow part where the pink squiggle is, this is part of this is a service that is effectively, not even effectively, it's 100% waiting on that blue bar to finish, right? It's waiting on the blue service to complete, which means that the critical path of my software runs through that blue part. A way to think about this is I could, improve the performance of the green or the, yellow or the pink part by 15 or even 50%. But unless I improve the performance of that blue service, then I'm not making a huge impact to the overall latency of this request. So this is useful for a couple different things. Rebalancing fan out scenarios is a good one. This is another internal example from live view. And what you can see here is we've fanned out this one request over, three routines or three different, client requests to a server. And if you look at the bottommost green bar here, you can see this one takes significantly longer than the prior two. Now, what this tells me is, I should figure out a way to reduce the time spent on that bottom one and kind of rebalance it so that all three of these are taking roughly the same amount of time. Because if I just, maybe if I didn't have this data and I just said like, oh, I need to, 2 seconds, that's a really long time, and I didn't know which one of these specifically I should work on, then maybe I would reduce the, time spent in the first or second one. But again, that's not really going to help because I'm still gonna be waiting on that third one, that slow one. And you can apply this by using something called Amdahl's law to sort of think about this. If you take a trace, if we actually take that prior trace and we sort of collapse it into two parts, the A and B. If I'm given a choice between speeding up A and B, then a 50% improvement in B is much better than a 50% performance improvement in A. More importantly, no improvement in A will ever improve the overall performance by more than 15% because A is only taking up 15% of the total time here, right? This was originally used in parallel computing, but again, as long as you're kind of able to visualize your data and think about it in these certain ways, then you can apply it to performance in a distributed system. To really oversimplify, if I compare these two things, I'm going to get the biggest benefit by optimizing the biggest part. That's in essence the long and short of what Amdahl's law says. Obviously, I want to be doing the second one, right? Obviously, I want to be, reducing or increasing the performance of service B here, or the groups of services represented by B, because not only will I not get much return on my investment by optimizing A, but I also now have a way to understand like what the maximum return on investment I can get is. If I'm looking at something more complicated where I've got 20 services, let's say, I can be like, okay, well, if we can't touch these because this is some legacy code or this is a service that we can't do anything to, we could actually look at that and make a definitive statement of like, well, this is the theoretical maximum performance we're ever going to get out of this API endpoint because of the legacy software, which could be an argument for like, okay, we need to actually go through and do some big refactoring or whatever. This is something that they saw at Google a lot. If you search for something on Google, you get all these different types of results. So all of those, different things are actually owned by different teams. And the news stuff, the Android store search, the knowledge card, all that. Application of Amdahl's law let them go and say like, okay, since these are all different services returning these results, which one of these do we need to improve, and what, is there something we can do to make the overall load time faster. This also lets you rule out categories of work too, right? This lets you say like, oh, well, I don't need to do A, B, C, D here. I need to work on E. Because I know that improving A, B, C, D isn't going to actually result in any change to what the end user perceives in terms of performance. So this is a really important tool for prioritizing engineering work. Finally, I'll talk about how tracing helps you manage costs. So a lot of things we talked about are impact cost, right? Like developer velocity impacts cost, performance of your application impacts cost. And there's kind of two types of costs. Or three types of costs. There's, OpEx or developer time costs. And then there's sort of like your revenue and reputational costs. Like, am I failing to convert? Are people unhappy? But there's also this infrastructure cost. So how much compute am I using? How much storage am I using? How much, database API calls am I using? And finally, there's this monitoring costs idea. So monitoring costs can be a really sneaky one for people to keep track of. If you think about logs, then you can actually calculate how much logging costs. So if we say, okay, I'm gonna do like open source everything. So I'll do elk, and I want to ingest 50 gigs of log data a day. I want to retain that for 14 days, and I want it all, highly available, so nothing going into cold storage. Then here's some prices. I pulled these from AWS a while ago. 716 bucks a month, not a ton. However, when you factor in the engineering time it takes to like set that up and maintain, my logging stack, and 50 gigs of logs is not a ton, honestly, but these costs start to increase very, very quickly. And it's the human costs, it's the operational costs that really start to kind of drive it up. So if we can take our spans, we take our distributed traces, and we kind of offload our logging into that, then we can start to see some savings. So we can take logs and attach them to spans, and then we can use traces to figure out what logs are important and what logs aren't. Just by doing that, we can make a huge cut to our logging spend. Simply by looking at a trace can really easily tell us if something failed on a request route or not. So a steady state system is very boring. You probably want to throw most of that away, but anytime an error occurs anywhere in a request, then that's potentially interesting. So if your only discriminator is, I want to keep all the logs attached to traces that have errors, then you're suddenly making 50% or greater cuts in your logging spend just from reducing the amount of data you have to ingest, and you're reducing the amount of time it takes for a human being to interpret that because you've added context now for whoever's going and doing the investigation. So let's get towards the end here and talk about how you would deploy this. How would you use it? Tracing isn't a migration. It's not like a one-step, one-click thing. It's a journey. It's not all or nothing. You want to figure out ways to do it to get incremental value. I hope by now there's enough examples of like cool use cases and ways to generate value that you see the benefit of starting it. And you want to find a place that it's easy to integrate and start there, and then use that incremental value to kind of make the case for the next step. Ultimately, tracing is kind of a developer tool, right? It's a dev tool in the most purest sense of the world, because most of the people that are going to be using it, especially at first, are going to be developers. So if developers are using your tracing tool, then that's a metric success. You want to start with things that are kind of on the critical path for your users, right? Look at kind of the edge of your system, maybe an API gateway or a proxy. Figure out, how do you instrument that? Maybe pick the most important services on that and start instrumenting those. And that helps you kind of build a case for kind of going further and further and adding more and more and more. You can check on our website. We actually have a guide, like an ebook for this that's pretty cool. And there's really a lot of great getting started material for tracing, I would say, that can help you. You can also like contact us, and we have people that will gladly set up a demo for you and show you how to get started. Once you've done that first part though, and you kind of have some organizational buy-in, you're starting to get this implemented, then I think the next important thing is to set up like a playbook for how do you kind of go forward. So we talk a lot about this in the book, about establishing sort of a checklist for tracing. So when a new service gets deployed, does it have the right tags and the right metadata on the spans? How are you using this to, defining ways to sort of use this performance data in your development process and have it feed back on itself? You want to find places that make it easy. The ultimate goal here is you should have tracing be a part of shared code. So if you have like a microservice framework that you all use, or if you have, some sort of utility library that everyone is using, then that's where you kind of want to put the tracing. That's where you want to put this instrumentation code, because that will make it a very easy on-ramp for new teams to adopt it. And then finally, you want to integrate this into what people are using today. Like I showed earlier, if you're using PagerDuty, okay, then you should integrate, you should link alerts to traces. If you're using some sort of CI/CD system, then like GitHub or GitLab or Bamboo or whatever, then being able to kind of jump between a deployment and a trace is very handy. When you do like issue tracking and things like that, it's usually a good idea to like, hey, here's a representative trace of the problem we're trying to fix. There was a story I like from when Google did this. They actually, when Dapper was very new, I forget the exact number, but they increased utilization like just by a factor of 10 overnight simply by integrating. There was a sort of a but there was like a performance tool that a lot of devs already used, and they went in and they added a link from that tool to Dapper, and suddenly just like a ton of people started coming in because it's like they put the traces in a place that devs already expected to find this kind of information. So someone would click on it and be like, oh, this is really useful, and then they'll come back again and again and again, right? The key to all of this is to, of course, build observable services, to build and build using open standards. So OpenTelemetry is a good example of this. If you have any questions with OpenTelemetry, feel free to reach out. I'm a maintainer. I do a lot of stuff with the community, but it's a CNCF project, and it makes it super easy to like create traces and metrics and sort of aggregate them and ship them off to various places. It's completely open source. There's some work required to integrate this, but it's pretty straightforward. There's a lot of great auto instrumentation options to kind of get you started quickly. And depending on the language you're in, like if you're in .NET, this is all integrated into Microsoft System.Diagnostic stuff. So it's literally just, import some things in your CS proj and add a couple lines of code, and boom, everything is all the Microsoft stuff at least is instrumented. It's great. So in summary, distributed tracing is going to provide you a bunch of actual tangible benefits and use cases, and all of those map over to some business value goals, right? And some of them even go to different ones, right? Like if you can root cause problems faster, then that's going to improve your developer velocity, but it's also going to be manage costs. If you're able to optimize, do more targeted optimization of your code, then that's going to improve performance and help you manage costs. The great thing about tracing is that it's not just a point solution for a point problem. It's really a better way of handling a lot of these really complex and thorny issues around distributed systems that we have to deal with every single day. It puts answers in context. It helps you narrow the search space for what's going on, why is it going on. And when you're sitting around and you're looking at a terminal, or you're looking at a Jira ticket and you're saying what changed, you're desperately trying to figure that out, distributed tracing is going to be there to give you that clarity, I think, and it's going to do it better than anything else out there. So with that, I would like to invite you to check out Lightstep. If you go to go.lightstep.com/request-a-demo, you can see more about how we do tracing at Lightstep, the power of our tools, and also just ask any questions about like tracing. And if you have any questions for me, looks like we have about 10 minutes. I would be happy to answer them.
So, Austin, we do have a few questions, if you don't mind.
Yeah.
First of all, before we get to questions, what a great presentation. The whole observability space it's really perked up lately, and we cover it a lot here at Media Ops and the various players. And one of the things is, the role of the CNCF, the role of open source that's allowing people to use products like the Lightstep service product integrated with some of these great open source projects that are out here, and it's putting such power in the hands of people that before it was kind of feeling in the blind a little bit. But that being said, thank you for a great presentation. Let's get to our first question, and that is, what are your thoughts about open telemetry compared to Dynatrace? I heard that Dynatrace scales well compared to open telemetry. And Austin, I understand your reluctance to badmouth a competitor or.
No, I mean, I'm not. No, it's not that. I think that I know some people that work at Dynatrace. I think it's a good product. What I want to talk about really is the distinction, like between like Dynatrace and Lightstep and Datadog and Honeycomb and whoever else and OpenTelemetry. So OpenTelemetry really specifically is, an open source project that provides a unified API, SDK, and tooling to help you to build observability into cloud native software. So Dynatrace, yes, it has libraries and SDKs to integrate it into, your software, but Dynatrace, the product, is it's an observability tool. It helps you interpret that data and find answers to your questions in the same way that Lightstep is an observability tool and helps you find answers for your questions. The same way that Honeycomb is an observability tool that helps you find answers to your questions. Now, each of these tools, these analysis engines have different features and functionalities and capabilities. And like I said, I'd encourage you to take a demo with us and we'll show you ours. But there's a pretty growing movement to sort of the stuff that OpenTelemetry does is pretty commoditized. And there's a real movement from major observability vendors to really take a lot of those APIs and SDKs and things that they were doing, in a proprietary way, and kind of put those in the open source world so that everyone can benefit from them, not just people that use their product. I'd point to New Relic, which announced a couple weeks ago, they're open sourcing all of their agents and they're hoping to use those to contribute those to OpenTelemetry so that anyone using OpenTelemetry would have the benefit of like the New Relic agents, right? And then you'd be able to take that data that those agents generate and send it to any sort of analysis tool you want. So you could send it to Dynatrace, or you could send it to Lightstep, or you could send it to New Relic or whoever. So that's really the distinction, right? I think for the most part, the real question to ask is like build versus buy. So you could use OpenTelemetry with a completely open source, analysis engine, right? You could use it with Jaeger, or you could use it with Prometheus, things like that. I do think that I'm obviously biased, but I think for 99% of people, you're going to be better off buying a tool to do the data analysis, simply because, we're working on this every day, right? We're thinking about these problems in a different way than most companies are. So would you rather kind of have, an entire vendor that is sitting there figuring out how to really, generate a lot of value out of the telemetry data your application produces versus a couple people sitting around like trying to keep Jaeger running or trying to keep Elk Stack running, right? don't think there's a problem with any of those tools, I should say. Like there's Jaeger's a great trace viewer, elk stack is fine. And I think it's a better world that we live in that you have the option to kind of use free and open source software. But if this is a business and you're trying to like think about this in terms of a business, then I tend to say, you know, you should buy rather than build.
Excellent. Good stuff. Actually, we just got to thank you for you on that one, Austin. All right.
No
We
problem.
have 5 minutes though here, and I've got some other questions lined up. Before we do, I'm supposed to announce, and I apologize, I don't do a lot of webinars as much as I used to, but we do give out Amazon gift cards, not to everyone, but we do pick a few winners every day, every webinar. And today's webinar winners are Kevin W., Michael C., Debbie C., and Nick D. And our team will reach out to those folks and get their addresses or what have you for their Amazon gift cards. And thanks for joining. Thanks for joining today. Another thank you here for Austin, I see. That's great. And maybe
Thanks.
one more question.
Yeah, any more questions? I also ran a conference on Animal Crossing if anyone wants to ask about that.
Okay, we'll put it out there for you.
Yeah.
Just what's, when we talk about the difference between tracing and APM, right? To me, APM is sort of an old word. Then we had AI ops, and now observability is all the rage. And now we've got tracing. The difference succinctly between APM and tracing.
Yeah, I mean, I think that's a great question. They're the same underlying, in a lot of cases, the same underlying technology. You know, it's a marketing distinction, right? APM is application performance management or application performance monitoring. And really, it's the same sort of thing. It's looking at requests as they flow through your application from the perspective of an end user. There's some differences, right? Like I think observability is really focused on the idea of having complete end-to-end visibility, starting at a client level, either web client or mobile client or native code or whatever, and then being able to go all the way back to the database. Whereas a lot of APM tools, I feel like, focus just on sort of back-end technologies. But yeah, same thing with like synthetics or like real user, RUM or whatever. Like these are all just marketing terms. There's some specific kind of wrinkles that distinguish them, I would say, between like a pure tracing tool, but they're all built off of tracing at the core. That would be my best way to describe it.
All righty. We're about at the top of the hour. Austin, let me join the 6 other people who chimed in here to say thank you for a great session, man. This really good stuff.
No problem.
Yep, and many thanks to our friends at Lightstep. Just good stuff coming out of Lightstep, and supporting open telemetry and a lot of these CNCF projects. And I should give a shout out that the CNCF KubeCon virtual event was ongoing yesterday and today for anyone who's wants to jump on there. It's a lot of learning, a lot of great sessions happening there. But we're going to call a wrap on this Media Ops webinar from DevOps.com. I want to thank everyone for joining, and anyone watching this on demand. It's a great way to catch our webinars, but not quite as good as being on live when you can actually ask the presenter live questions. But it's certainly better than nothing. And we hope to see you on another webinar soon. Austin, again, thanks very much. Thanks to everyone for joining. This is Alan Schemmel. Have a great day, everyone.